Imagine it's a Black Friday. Amazon is receiving millions of orders every minute. Everything looks perfect. The website is fast. Customers are shopping. Payments are flowing. Revenue is pouring in. Then suddenly the website becomes slow. Orders start failing. Customers cannot check out. Engineers receives alert. Management joins emergency call. Social media start exploding and within minutes millions of dollars are being lost. Now, here is the interesting question. Did Amazon engineers forget how to build software? Of course not. The reality is much simpler. Every system eventually fails. Not sometimes, not rarely, always. If you build system long enough, something will break. A server will crash. A network cable will fail. A developer will deploy bad code. A database will stop responding. A cloud provider will experience an outage. Failure is not an exception, failure is normal, and that's why one of the most important mindset shift in system design is this. Don't design system assuming everything works. Design system assuming everything eventually breaks. Today we will learn why system fails, the major categories of failures, real world example, and why senior engineers think differently from beginners when designing systems. The biggest beginner mistake is when beginners design system, they usually assume everything works. Let's look at this architecture. A user sends a request. The request reaches the load balancer. The load balancer forwards it to application server. The application server queries the database. The database returns the result. The response goes back to the user. Everything looks perfect, and that's exactly the problem. Nothing in this diagram has failed yet. A beginner sees this architecture and thinks looks good. A senior engineer sees this architecture and immediately asks, what happens if the application server crashes? What happens if the database goes down? What happens if the network fails? What happens if the load balancer stops working? The difference is that senior engineers assume failure from the very beginning. Let's talk about the reality of production system. Production systems are messy. Servers crash, hard disk fails, network becomes slow, cloud providers have outages, developers make mistakes, configurations get corrupted, dependencies stop responding, eventually something breaks. The question is not will the system fail? The question is when will it fail? And how prepared are we when it happens? Now let's try to understand some failure category. The first obvious failure category is hardware failures. Computers are physical machines and physical machines eventually fail. Hard disk die. Memory becomes corrupted. Power supplies stop working. Entire server suddenly disappear. Let's follow this scenario. Our application is running perfectly. Everything depends on a server. Then suddenly the server crashes. Maybe the hard disk failed. Maybe the power supply died. Maybe the machine overheated. It doesn't matter why. The result is the same. The server is gone. And every service running on that machine disappears with it. This is one reason we never trust a single server in production. The real world example of it is imagine Netflix store all video data on single server. Sound crazy, right? Because if that server dies, Netflix disappears altogether. That's why large system always assume hardware failure will happen. Not might happen, will happen. Next failure category is software failure. Interestingly, hardware isn't the biggest problem anymore nowadays. Software failures are often more common. Let's walk through this example. An engineer deploys new code. The deployment succeeded. Everything looks normal. Then user starts arriving. Suddenly the application crashes. Maybe a bug exists. Maybe memory usage explodes. Maybe an unexpected edge case wasn't tested. The infrastructure is healthy. The hardware is healthy. The software itself caused the outage. Many major outages happen because of software changes. A single line of code, a bad configuration, an untested deployment. Sometimes one engineer can accidentally bring down an entire platform. Failure category 3 is network failure. Now let's talk about most confusing category, network failures. Because unlike server failures, networks can fail in strange way. Let's follow this request now. Service A needs data from service B. The request receives service A. It enters the network. Then something goes wrong. The network connection breaks. Now service A cannot communicate with service B. Here is the tricky part. Service A doesn't know whether service B crashed or whether the network failed. From service A's perspective, both situations look identical. This uncertainty makes the distributed system difficult. Now, why networks are so scary? Networks can fail partially. That's what makes them dangerous. Imagine server A can reach server B, but server B cannot reach server A. Or 50% of requests succeed, 50% fail. Or requests eventually succeed, but only after 30 seconds. These situations are much harder to diagnose than a server simply crashing. Failure category 4 is human failures. Now let's talk about the most dangerous component in any system, humans. Let's walk through this scenario. An engineer makes a configuration change. The change looks harmless, maybe a firewall rule, maybe a database setting, maybe a deployment script. The change goes to production. Suddenly services stop communicating, traffic starts failing, an outage begins. The infrastructure is healthy, the code is healthy, the problem was human error. The surprising truth is many famous outages weren't caused by hardware. They weren't caused by software also. They were caused by humans. A wrong command, a deleted database, a misconfigured network rule, a deployment mistake. Humans are incredibly creative at creating failures. Failure category 5 is dependency failure. Modern application depends on many external systems, payment providers, cloud services, databases, authentication provider, third-party APIs, and every dependency introduces risk. Let's follow the request. A customer wants to make payment. Our application forwards the request to payment provider. Now imagine the payment provider experiences an outage. Our application may still be healthy. Our servers may still be healthy, but customers can no longer pay. Why? Because one dependency failed. Modern systems are only as reliable as their dependencies. So we need to consider the mindset like the everything is on fire eventually. This leads us to one of the most important lessons in system design. Beginners ask, how do I make this work? Senior engineer asks, how does this fail? Every architecture diagram should trigger failure question. When a senior engineer sees this diagram, they don't focus on the happy path. Instead, they ask, what if the load balancer dies? What if the application crashes? What if the database becomes unavailable? What if the network fails? What if the traffic suddenly increases 100x? Every component is assumed to fail eventually. This mindset changes everything. Now why we study failures? Because every topic in rest of this module exists to handle failures. Why do we need replication? Because server fails. Why do we need failure? Because system fails. Why do we need disaster recovery? Because region fails. Why do we need health checks? Because services fails. Why do we need retries? Because network fails. Why do we need redundancy? Because everything fails. The entire field of reliability engineering is built around this reality. Now let's try to understand the trade-offs for designing for failures. What are the advantages if you design something for considering the failure? Higher availability, better reliability, better user experience, faster recovery, fewer outages. And what are the disadvantages? We will have more infrastructure, more complexity, higher cost, more monitoring, more operational overhead. All these things are the disadvantages of designing for failure, but it is worth. Now, few of the frequently asked questions in the interview. What are the major categories of failures in distributed system? So we have seen, right, hardware failures, software failures, network failures, human failures, dependency failure. Second question can be which type of failure is most difficult to diagnose. So we have seen network failures are often the most difficult because system cannot easily distinguish between network problem and service failures. Next question is why should architect assumes failure will happen? Answer is because failures are inevitable in large scale system. System must be designed to tolerate failures rather than assuming they won't occur. Question 4 is what is a dependency failure? When an external service that our application relies on becomes unavailable, that's when dependency failure will happen. Why are human failures so common? Answer is because deployments, configuration changes, and operational mistakes can accidentally introduce outages. Now, some of the common beginner mistakes in this area. Mistake 1 is designing only for the happy path. Production systems spend their lives handling failures. Mistake 2 is assuming server never crash. But the reality is every server eventually crashes. Mistake 3 is ignoring dependency failure. But the reality is third-party system failed too. Next mistake is thinking cloud providers never have outages. Even the largest cloud providers experiences failure. So what are things we have seen in this video? System fail because of hardware failures, software failures, network failures, human failures, dependency failures. The most important mindset in system design is everything is on fire eventually. Failures are not exceptional. Failures are normal. The goal is not to prevent every failure. The goal is to design systems that continue working when failures inevitably occur. Great systems are not the ones that never fail. Great systems are the ones that recover gracefully when they do fail, and that's the foundation for everything we will learn in reliability, availability, and failure.